Time-restricted eating drives pancreas, liver, muscle, and fat cells to produce energy while keeping insulin normal.
When you ask people to fast, or when you ask people to restrict their calorie, count calorie, it's a very stressful experience. Not eating for a day is a very stressful experience, and people don't enjoy that. They don't do it every day. But eating within 10 hours, we realized that people actually enjoyed it. So that's why they
Yeah.
stuck to it. We have the luxury of knowing what else improves health. So, for example, we know metformin, for example, which mimics fasting, acts on a kinase called AMP kinase. That's a fasting induced kinase.
AMP kinase, AMP activated protein kinase, an enzyme that plays a role in cellular energy homeostasis, activates glucose and fatty acid oxidation when the cellular energy is low.
It triggers fat oxidation and a lot of different things. What we find is when animals do this time restricted eating, then their um, pancreas gets enough rest to prime the cells to produce just enough insulin when the mice start eating. So the pancreas does not produce excessive insulin during fasting time. So the fasting insulin level actually drops. In liver, our liver produces some glucose when we fast. It's known because the liver has to produce some glucose that will fuel our brain because our brain is dependent on glucose. But in type 2 diabetes, in many disease, liver disease, this mechanism that should be on only when the liver is when we are fasting stays on throughout 24 hours, as if the circadian rhythm in glucose production is non-functional. So that contributes to increased glucose because the liver is producing glucose, we are eating, all the glucose is flooding our blood. And when mice do this time restricted eating, this process called gluconeogenesis, making new glucose, that shuts down during the eating period. So for half of the day, the liver is not producing excess glucose. And that might partly explain why the glucose levels remain normal. The third thing is when I say this gluconeogenesis, that glucose is made by breaking down protein in the muscle. And if for half of the day the liver is not making that new glucose from breakdown muscle protein, then the muscle must be getting healthier. And that's exactly what we find. At least in half of our mouse experiments, we have seen the muscle mass increases under time restricted. And it's not only just dysfunctional muscle mass that is increasing, these are functional muscle mass because these mice can stay on a treadmill for a very long time. They can exercise, they have much better motor coordination. And the same thing we find in fat tissues. During the fasting time, there is enough drive or enough deficit of energy that the fat tissue now begin to break down the fat that's needed when we fast, and that fatty acid also comes to the liver, broken down again to ketone bodies, or ketogenesis happens, and that fuels the body. And all of these are interlinked because for this process, for the fat breakdown to happen, one thing that happens in the liver is excess cholesterol gets broken down, and that's because the circadian clock in the liver becomes more strong, and there is one of the clock component, clock protein, that is actually responsible for turning on this mechanism to break down cholesterol to bile acids. So we break down cholesterol, and our bile acids level go up, which is pretty good for us. And some of that bile acids go to the fat cells, and they tell the fat cells that it's time to break down your fat so that the liver needs some fat for making ketones. So now you can see that it's not one thing that happens during time restricted eating, at least 5 or 6 different things that we know for now, and that list is continuing to grow.
Time-restricted eating drives pancreas, liver, muscle, and fat cells to produce energy while keeping insulin normal. Asking people to fast or to count calories, it is very stressful. People don't enjoy that. But eating within a 10-hour window is enjoyable. That is why people stick with it. Why does time-restricted eating work? We know it improves health. For example, the drug metformin. It mimics fasting. It acts on AMP kinase. It triggers fat oxidation and other things. AMP kinase. AMP activated protein kinase. an enzyme that plays a role in cellular energy homeostasis, activates glucose and fatty acid oxidation when the cellular energy is low. When animals do time-restricted eating, the pancreas gets enough rest to prime the cells to produce just enough insulin when eating. It does not produce excess insulin during fasting. Fasting insulin levels actually drop. When animals do time-restricted eating, the liver, when we fast, produces some glucose to fuel the brain. But in type 2 diabetics, this production, which should only happen when fasting, happens all the time. Dr. Panda says, as if circadian rhythm and glucose production is non-functional. This contributes to increased glucose. When mice do time-restricted eating, this process, called gluconeogenesis, shuts down during the eating period. Dr. Panda says, for half the day, the liver is not producing excess glucose. Glucose levels remain normal. Gluconeogenesis. Glucose is made by breaking down protein in the muscle. If for half the day muscle protein is not being broken down, then muscle must be getting healthier. He says, in at least half of the mouse experiments, muscle mass increases under time-restricted eating. The muscle mass that increases is functional muscle mass. We find the same in fat tissues. During time-restricted eating, there is enough energy deficit. Fat tissue now breaks down fat needed when we fast. Then comes to the liver, breaks down into ketone bodies for fuel. These processes are all interlinked. For fat breakdown to happen, excess cholesterol in the liver must be broken down. The circadian clock in the liver becomes stronger. One other clock-driven protein breaks down cholesterol into bile acids. Some bile acids go to the fat cells and tells them the liver needs the fat to create ketones. It is not one thing that happens during time-restricted eating. There are 5 or 6 things that we know for now, and that list is continuing to grow.
Annotated and summarized. Easy to share with loved ones.
To view and print these summary notes, see the description below the video title. To view and keyword search this channel's hundreds of videos, organized by topic and by doctor, go to doctorstotrust.com.